Okay, so I will share this recording with everybody for everybody who's listening today. Okay, so we'll get started. So thanks again for joining. So let me see. So 2 weeks ago, it was 2 weeks ago now, goodness me. 2 weeks ago, we started looking at operating systems. And I'm actually going to drag this over here for a moment. And I'm going to bring up MOS2. I'm going to bring up the Git repo with all the stuff in it. And drag those out of the way. I'm going to come into folder number 3. And I have 2 images in here, and these are the images that we were looking at last week. So you know how to start, what happens when your system starts up. So we said you have a BIOS, the basic input-output system on your motherboard, which is going to delegate to your operating system like Windows or OS X or Linux or whatever it is.
I can't see anything on your screen. Is there?
Oh, sorry, my apologies, guys. Sorry. Thank you. It's going off the wrong monitor. Okay, you got to see my nice my nice desktop background there, right? That's Stockholm, where I was a few years ago before the pandemic. Right. So sorry. As I was saying, we start the BIOS loads your operating system, which is Windows or whatever. And what we exclusively was talking about last week were processes. So we brought up Process Explorer. Some of you, Ian, you brought up Process Explorer on Windows, and we had a look at some of the processes that were running, and we looked at things like, again, the parents-child relationship between processes, and we looked at how to kill particular processes and whatnot. But generally speaking, what we learned was that a process is a process is what we call the context of a running program. So when you launch your web browser, such as Firefox or Chrome or whatever your favorite web browser is, when you launch Discord or you launch Counter-Strike, there are one or more processes running on your system to support that program, okay? At least one. And we also talked a bit about how to schedule processes for the CPU. So we said that if you have one process, we're disregarding multi-core processors or anything like that. If you have one CPU, one processor, one Intel processor, don't make me do the chime. Dun, 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 dun. Okay. I'll have that on the recording now. Hear me. If you've one processor on your computer with one core, your computer can only execute one program at a time. And that is why your operating system has to schedule processes. So for all the processes running on your computer, if you're listening to Spotify or you have a YouTube video pause, you've Discord in the background, and you're a Microsoft Word document at the front of your thing that you're working on for some homework or whatever, your system, your operating system has to schedule all those processes to have equal amount of time to execute their code in the processor of the computer. So we talked a bit about that process, which was called scheduling. And now what we're going to do, that was the first thing. And then what we talked about was the states that processes can have. It'd be really nice if I could bring that over here. So we talked about essentially, well, ignore kill for a moment, the life cycle of a process. So we have ready processes, which are processes that are ready to execute in the CPU, like, as I said, Microsoft Word, Discord, or Google Chrome, whatever programs you want. These are programs that are ready and waiting for time to run in the CPU. And a process goes from ready state to running state. One process can be running in the CPU at any one time. So in this example, we have WebEx, because you're all on WebEx with me right now. We have WebEx running in the CPU. It's been given 30 milliseconds to execute before it either has to go back to the ready queue and await its next turn, or if it's a process that has to stop and wait for some event to complete, like for the user to type something into the keyboard, like the Python programs we looked at where we type in our names and things, processes that are not ready to run in the CPU because they're waiting on something, they become blocked. So blocked processes, so processes that are waiting for some event to complete. So we saw the Python programs where you could type in your name, and while the program is waiting for you to type in your name, that Python program is blocked. But once you type in your name and you hit the enter key on your keyboard, the program has the information it needs to continue execution, so the process goes back to the ready state. It goes back into the queue of ready processes. And again, it'll await its turn until the scheduler in your operating system decides that it's time for it to run in the processor again. And then obviously when a program is completely finished, just turned off or has finished all its work, we can kill the process or it becomes terminated. So that's another state. So for all of you who were missing last week, that's a very brief synopsis of what we looked at last week. The good news is I have no new homework, or I shouldn't call it homework. I have no new challenge exercises for you this week based on what we did last week because it was my birthday. So I'm going to give you all the week off with no challenges, and of course that's just my excuse for not having them prepared. and I don't have the solution videos ready for the exercises from the previous week up yet, but because again I was on vacation the last 2 weeks, but I will have them at some point and I'll get them to you. So now what we're going to do today is we're going to, as you alluded to, Kyle, earlier, you have your Ubuntu box there and I have my Ubuntu box here. And what we're going to do is we're going to translate some of this stuff into practical activities using Linux because it's a much better way to learn about operating systems than doing things on Windows, which is a pain. So we're going to look at lots of different features. Well, we'll look at a fair few features on different activities on Linux today. This session is somewhat unstructured. We're just going to be pretty free form, and we'll just kind of take it as it goes. Some of the different commands and different things you can run on your Ubuntu system in regards to processes. We'll look at some Python, and I'd like to look at things. Well, and we'll get into that. So we'll try and look at as much as possible. Now, before we get into anything of the Linux stuff today, does anybody want to ask me any questions about anything I've said so far, or does anybody want me to recap anything about last week? Just whatever you want, you can ask away now before we get started. And take your time, Ian. There's no rush. You can just watch along. The thing is being recorded now, Ian, so you'll be able to watch it back and repeat some of the things we do. If you have your system there, whoever has a Linux terminal, you're welcome to do some of these things as I do them. Okay. So are there any questions before we get started? I'll take the silence as a no. Okay. Okay, cool. So let's drive on. So what am I going to do now? I'm going to bring over my Linux box, I guess, onto the screen here. Okay, and oh no, actually, do you know what I'm going to do? I'm not going to do that. Hang on, I told you this. I have a problem with the screen resolution. I'm going to actually stop sharing, and I'm going to share another monitor. Stop sharing. Hopefully this will work out. Share screen. This one. So can everybody see my this kind of red purplish Ubuntu background on my screen share now? Yes.
Yeah.
Good. Okay. And I've just realized you're all going to hate me. I'm going to turn it off and start it again because I've noticed because I tried to reduce the size of it earlier to work on the smaller monitor, and now it looks really small. So I'm going to make it bigger for you to kind of try and make it easier for you to see. So bear with me. Display, and I'm going to scale it up to 175%. Saving and start. Okay. Now, while this is starting up, I have a question for you to recap from 2 weeks ago. The first thing we're going to have a look at. Again, let me just get my WebEx icon. I have so many bloody windows now for this particular session. Can anybody remember we were talking? So the last time we were meeting, we were talking about what kind of processes, right, should have the highest priority for the CPU. So if you are the scheduler in the operating system and you have to decide which kind of processes should have the highest priority for time to execute in the CPU. Oh, we have a hand up. Killian. Without even finishing the question, can you tell me what you think the answer is?
Is it processes you have open?
And what exactly? What kind of processes did you have open? Do you think? I know
Like-
where you're going with this. I'm just wondering if you can elaborate a bit further.
Like WebEx now.
Okay, exactly. And why?
things
And
that
why?
you
Exactly. And why? Why would that? And the reason I shouldn't say why. It's pretty obvious, I guess. Correct, Killian. Yeah. So processes that are like right in front of me right now on my window that I'm directly interacting with, like WebEx, because we're all on WebEx, would have the highest priority for the CPU scheduler. Okay. Now. And if I remember, I'm not sure, it was, I think it was you, Ian, who suggested it last week. You thought that maybe the highest priority processes should be some of those system ones. We saw there was a whole bunch of like system ones running in Process Explorer, right? But we said, yeah, and basically what we were saying is that system processes, you see, all those system processes are in the background. They're there, they're running, they're getting time in the CPU, but they're not exactly front and center visible to the user of the operating system. Okay, so those would tend to have lesser priority, but they need to have priority all the same. Now, the reason I'm bringing this up, and I'm going to open my terminal now. I hope this is a bit better in terms of size. That is better. Yeah. Okay. Now, so what I want to explain here is that we have ways of describing those processes. Okay, those very high priority processes that are on our screens right now, like WebEx, as Killian said, or Discord, or whatever you're doing in the background there. There's a word for those. We call those foreground processes. Foreground processes. Okay, by foreground, like it literally means like they're at the front. They're most important. So WebEx is a foreground process. If I was browsing with Firefox there in my virtual box, my Ubuntu virtual box, that would be a foreground process. I have a terminal window here, right? And you can see some of the problems with my Soul machine. It's entering multiple characters when I type for some reason. When I type things into the screen here, this is also a foreground process. Okay, so to be very clear, it's these foreground processes that have the highest priority. Okay, as opposed to the other type of process. Well, if you're not in the foreground, then what are you? You're in the background. Okay, so we have foreground processes and we have background processes. Okay. Now, I just want you to bear that in mind. We're going to revisit that in a moment, but that's the very first thing I have to say, right? Now, what we want to do is we want to get a sense of how these things actually work in Linux. Now, again, last week we looked at Process Explorer, but today we're looking at Linux, so we don't have Process Explorer. What we have is something like this. And if you're at home now and you have a Linux terminal in front of you, this is where you can start typing along. Okay, I'm going to run a command here in my terminal, ps -aux. Okay, and I'm going to hit that in. And now we've got a whole load of output here. Now, what we see here is essentially the same kind of thing as we saw on Process Explorer with Windows last week. This is a list of all the running processes on my Linux machine, and as you can see, there is a lot of them. There's a lot of them. Okay, it's not as user friendly looking as Process Explorer, but nevertheless, it's the same kind of information. Now, I have a question. We're going to have a look at this table, and then we're going to move on a bit. Okay, and we're going to do some Python programs with these processes to demonstrate a few things. Okay. Now, what I want to do. A question for you all? Does anybody remember from last week what was the name? I showed it to you on Process Explorer. What was the name of the first process that runs when your system starts up? Put your hand up if you can remember that. The name of the first, we saw it on Windows. What was the name of the first process that starts when your computer comes up? Can anybody remember? Ian, Cullinan, hello, go first. What is the answer?
Was it Win-ish?
Correct. Exactly. Well done. It was WinInit, right? The key word in there being init. Init is short for initialization. And as it happens, on Linux, we have the same thing. If I scroll to the top of this list, and you have to bear with me, guys, like I said, the performance of my VirtualBox on my Mac here is absolutely atrociously slow. That's why that's not just coming slow over the WebEx, it's slow on my laptop. There we go. And have a look, guys, at here's the top of the table there. So what we see, we have the user, PID, percentage CPU, percentage memory. I can't remember what those two things are, VSZ and RSS. TTY, stat, start, time, and command. And look at the command on this first one here, guys. It's init. So Linux also, or our Ubuntu at least, also has an init process. So init is the first, is like Windows where we start with WinInit. Init is the first process that comes up when you start up your Linux machine, okay? And what I want to draw, I'm going to highlight that line. And what I want to draw your attention to is PID over here. Can anybody remember, because it was the same thing again on Windows with Process Explorer, what does PID stand for? Can anybody remember from last week what PID stands for? Niall Kelly, hello, go for it.
Process ID?
Correct, process ID. Thank you, Niall. Yeah, process ID. So PID is short, PID or PID is short for process ID. So one of the things we said last week is that every running process has its own PID. And what do we know about the initialization process, the init? It has a PID of 1. So the init process always has an ID of 1. Okay. Very good. Now, so that's the first thing. We see things like percentage CPU. Again, we kind of saw that with this is, I should probably point out, this isn't an interactive display like Process Explorer was. Last week we saw Process Explorer was constantly updating, showing real-time information about what was happening on your Windows system. This is not real-time updating. This is the report as it was when I ran the command. So when I ran the command, the init process had 0.4% CPU utilization and didn't seem to be using a lot of memory, okay? And it has the time as well that the system started up, okay? Now, the other thing I want to draw your attention to is we also over here, now we did not see this in Process Explorer on Windows because it doesn't work the same. We also have this user column, right? So we have user column, and note the user for all this process and all of these processes is called root. So we have the root user. The root user is like the super administrator of a Linux system. He is the ultimate boss. He is the head honcho, the big cheese, right? Whatever you want to call it. He is number one, okay? And the root user is responsible for running the init process and all the other processes, okay? Now, what I'm going to do is I'm going to come back down to the bottom, past all these processes. And I also want you to note there are some things here that are run where the user is not root, but the user is me, Michael. That's my user on this system. Let's have a look. Let's have a look at this one here, for example. There's Michael. This is it's a process owned by Michael. It has a process ID 2706, and it says bash. That actually refers to this terminal window, which is correct because I opened the terminal window. So, and it's a running process. It's a foreground process. We can also see, if you look at the last entry in the table, there's the command I ran to get this information, ps -aux. So that was also running at the time the report was produced. I ran it, so it's owned by me. It has its own PID. That process is no longer running, of course. Once it generated the report, it would have stopped. So that process is no longer running. So that process is terminated. Okay. Okay, that's cool. So now, let me see. It would be really nice if I didn't have to. Maybe I'm only interested like in the processes that are owned by myself. If I run a command like ps -aux. And one of the cool things I can do on my Linux operating system is called a pipe. I can pipe, which is like a vertical line, just like that. I can pipe the result of this command into another command. And what I'm going to do is I want to search for all the processes which are owned by Michael. I don't want to see the ones owned by root. So a quick way I could do that is I could do a search for all the processes run by Michael. And a very quick way to do that is to do something called grep. grep. And grep is what's known as a general regular expression. So I'm going to search for something based on some expression. So what I want to do, I'm going to type in a search term of Michael. I'm going to run that. And now all of a sudden I see kind of the same outputs, but notice I don't see any of the processes now that were owned by the root user. I just see the Michael processes. There's the top of the output there. So grepping for something is a really cool way, and this is the kind of place where I hope you kind of take mental notes or something, some of these commands, right? PS minus AUX, grep to search for something. These are the kind of things I'd like you to take away from this session. So I've grepped for Michael, and what it's done is it's filtered everything above to only show the lines of text that have my search term in it, which in this case is Michael. And it shows my search term in red as well. I searched for Michael, so there it is. Now let's see, has Calum like hacked my system and to see if any running processes on here. Because I see Calum has joined the call. Hello, Calum. Salutations and celebrations to you. Does Calum have any processes? Calum doesn't have any processes. What we're seeing here is the grep program running. And obviously I'm searching for Calum, so I have an entry in my list for that, but that process is owned by Michael. I don't see any process owned by Calum. Hello, Calum, how are you doing?
Good, thank you. Try it again now. Now that I'm back.
I bet. And here's the cool thing, guys. If I want to run that command again, if I don't want to type it out all over again, all I need to do is press up on my keyboard, and it brings me back to the last command I ran. But no, Calum still has not infiltrated my system. Oh dear, Calum, I'm disappointed, man. Okay.
Sorry, I'm a bit late there.
No, that's no problem.
Some desktop trouble.
Oh yeah, like myself the last time. Yeah, that's no bother. Okay, so there we go. So we can see our processes in Linux by using ps minus AUX, and I was able to filter the list by using a grep command. That's cool. Any thoughts or questions or feedback about any of that before we proceed? I've lots more to show you. So, okay.
When I use the command,
Say that
barely
again?
anything shows up. When I use ps minus AUX, like 4 things show up.
Are you running on your you said you were dual booting, right?
No, I'm kidding.
Oh, Killian, sorry, Killian, I don't have my list in front of me. You can cast. Well, so what are you running on, Killian?
I'm running on Ubuntu.
Are you using the Ubuntu subsystem, or are you using VirtualBox?
I'm using subsystem.
Yes, that one runs far fewer processes because that's not a full Ubuntu installation, right? That's why yours is running far fewer than mine. Because I ran it on my Ubuntu subsystem the other day, and I only had like 5 or 6 processes as well. That's to be expected. Like just to put this into context for you, right? Some of the things here. I'm sure I saw it there somewhere. Maybe I actually might have seen it when I ran it when I got all the output. So you won't see. Oh, jeez, I ran the wrong. Clear. There's a command that cleans up your window. Let me see now. There's why I knew I saw it somewhere. Look, do you see? Look at something like that, for example. We have a few processes here with GNOME in it, GNOME. So GNOME is the user interface, like what you see here, like all the icons on the side, none of which you have, for example, Killian. So yours won't be running GNOME, and there'll be a whole lot, because yours is only a kind of a virtualized, only a subsystem. It's only kind of like a shell of Ubuntu. You're not going to see all these running programs, because what I'm seeing here is a whole load of operating system utilities and services and programs, because this Ubuntu virtual machine doesn't realize it's a virtual machine. It thinks it's running on the desktop. So it's running all the systems and utilities required to manage the hardware of my computer. Yours isn't, Killian. Yours has been customly stripped down to only one kind of bare essentials. That's why you see so few things. And if anybody out there is running Git Bash, I hazard you'll see even less, because that's not even a real Ubuntu, you know. So your mileage will vary, guys, depending on what you're doing. So don't be alarmed; those things are to be expected. Anything else before we crack on? Anybody? Very good. Okay, so here's a couple of other interesting tidbits. Let's say I only wanted to get the last 20 lines of this output. I don't want to see, however, actually, before we even get onto that, it would be really, let's just strip it back a bit. It would be really cool if I knew how many processes are running on my system. Because we saw in Process Explorer last week, there was a count of running processes, but there's no count here. I'd have to count through them 1, 2, 3, 4, 5, but I'm not going to do that. I'm too lazy to do that. So wouldn't it be nice if there was a nice Linux utility that would allow me to count how many lines I have in my output here? And shock horror, there is, right? There's a word count program. So instead of piping or redirect, instead of piping my output from the PS command into grep, I'm now going to pipe it into the word count program, which is WC. Oh, geez, I'm not clicked into the window. Wait, hang on. WC. There we go. And if I do -L, it will count the lines. So if I run that, 200 was that there, guys? 209, right? Now we have to remember the first row in the output was a header row. It's just telling me like user PID percentage CPU so on. So that doesn't count. So it's actually -1. So it's 209 -1. So it's 208. So there's 208 processes running on the system at this time. So word counts is a very good tool to have in your repertoire of Linux, okay? I suggest you also run PS. So if Killian runs it, for example, he's only going to get like probably 3 or 4 lines in his output, okay? Now, let's say, for example, I only wanted to see the last 20 lines of output from this command. There's another command I can use called tail. Tail, not with 2 L's, with 1 L. Tail will allow me to see the bottom of output. So if I say tail -20 for the last 20 lines, oh, Jesus, I don't have it. Oh, I haven't spelled it right. I beg your pardon. It's my bloody keyboard here. Tail -20. Oh, I still haven't spelled it right. Goodness me. Tail -20. There we go. So that's only showing me the last 20 lines of the output. Whatever those last 20 lines are, that's what I'm getting. And as it happens, if I wanted to see the top 20 lines or the 20 lines at the top of the output, I could use the head command. If I do head -20, I'll see the first 20 lines. And I've also spelled that wrong, goodness me. Head -20, and there we see the top 20 lines of the output. So I can see the header row and then 19 other processes. Okay, so those are a couple of cool, useful commands to have in your repertoire. Okay, now as we go through the remaining online sessions for August and maybe into the beginning of September, I'm going to be showing you lots of other operating system commands. Okay. To do with, like, say, computer networking, probably databases, security, things like that. So if you have your Windows subsystem or your VirtualBox or your dual booting, like Kyle, whatever you have, it would be good to get familiar with these things, because I will introduce you to more commands as we get into the different topics that we're going to be talking about on a week-to-week basis, okay? So if you have the means in front of you, do try running these commands, okay? Now, what I want to do, I want to kind of try and finish off a bit on processes with what we've learned here. There's a bit more to say about the process output, okay? What we're going to do is we're going to look at some Python programs. And I also want to give a shout out to Padraig Kelly, who in his spare time was experimenting with writing a shell script. So a shell script is basically like a computer program that runs natively on your Windows. Hang on, I'm getting some chat messages here. Kyle, you keep getting a fail to unmount error. It sounds, if you're dual booting, as if something isn't correctly unmounting from the system, I guess. I'm not sure what's going on there. And Ian, I switched my laptop instead of my. You're having some audio issues. Okay, well, don't you? Okay, cool, Kyle. Well, don't worry, Ian. If you have any problems with the audio, you'll have the recording. So don't fret. Kyle, if you send me more information on Discord, afterwards, I can try and send you some guidance on what's happening with yours. Okay. So what we're going to do, as I was saying, is we're going to look at some Python programs in regard to the PS output that we're looking at here in terms of processes, okay? Now, I'm going to do an ls here. ls, by the way, is a command that will allow me to list my files in whatever folder I'm in at the moment. So I'm going to change into another folder. Oh, geez. I'm going to change into another folder here that I created ahead of time. I just need to clear that for a second, okay? Oh, there we go. So if I do cd, it allows me to change from one directory to another. We'll be looking at that before we finish talking about operating systems. And if I do ls, it stands for list. I can see the files in my directory here. Oh, I was talking about Parag Kelly. That's what I was talking about. Okay, so yeah, so I can see the files in my directory here. So ls stands for list. And what we can see here is I have a file in my directory called generator.sh, and that is Parag Kelly's shell script program. Parag, do you want to tell the world, by which I mean the 17 people on this WebEx, what does that script do that you were working on a week or two ago? If Parag is
Hi,
okay.
sorry.
Oh, hello,
I
Parag.
put it up there, 1 sec. Okay, so basically, what it does is it makes a list of every letter in the alphabet, and it generates a random string using that list.
Very good. Very good. Anything else to add to that? I'll take that as a no. Okay, that's cool. So Parag built like a random string generator. It has an alphabet, a series of, well, for the version of the script I have, it has a list of words, and when you run the script, it's going to print out. It's going to pick 3 words at random. So let me run it there. I can run a script on my system by doing ./ and the name of the script, as long as I'm in the same folder. In how paste. If I run this again, here not copy, and a third time, it's the copy. So the script, this command cat allows me to view a file. So cat will allow me to print out the contents of a file to my terminal. So here's Parag's alphabet. I don't know how to copy paste from Nano, but I'm not bothered to type out the alphabet. Just imagine it's here. So the version of the alphabet I have from Parag is these series of words. So we're not going to be talking about shell scripting in these sessions. I try and avoid shell scripting if I can, to be honest. So we're not going to talk about how the script works or anything, but just to say it's going to pick 3 random words from this list and then print them out. So if I run his script again, it picked out I'm, to, and type. So it picked out I'm, to, and type, which is over here. And again, so it generates a random number and picks that number, that item from the list, whether it's the 0th item or the 2nd item or whatever. So it's picking 3 and printing them out, okay? Thank you, Parag, for allowing me to use the script for a demonstration today. We're going to be using this in a moment. Now, first thing I want to do is I want to emphasize to all of you that Parag's script here, when I run it like this, it's running as a foreground process. Okay, it's running as a foreground process. It's, even though it doesn't have a window like WebEx or Discord or whatever, it is a program that I am interacting with through my terminal. and it's sending output onto the screen, right? So thanks Sky News, it is a foreground process. But Linux also provides a way to run a process in the background if I wanted to. So I could run Pari's script in the background. And the way to do that in Linux is to put an ampersand character at the end of the line. So I've just put my ampersand there. And if I run that now, we can see that we have this, we first get this output here, 1 and 2847. So what it actually did was it started one process and gave us a process ID of 2847. And then what it did was it proceeded to write out the contents of the script to my terminal window, how type copy on this occasion. And when I press the enter key on my keyboard, it now notes that the script is done. Okay. So that when I did that script was running in the background of the system. Okay. Now, what I want to do next will crash my VirtualBox. So I'm not going to do this in VirtualBox. I'm going to do this on my Mac, where I don't have such performance problems. I'm going to go to virtual computer. Is it capital V? Virtual? Yeah, or no, it's not that. Virtual computer science. Okay, clear. Okay, so and CD into number 4. And I actually do not have Pari script here, but I'm going to put it here right now. Generator. Actually, oh, sorry. I know why it's not. Actually, why don't I have? I was working on this earlier today. Oh, I seem to have misplaced the script. Never mind. It doesn't matter. We'll recreate it. So I'm just going to open a text. I'm going to open a text editor on my screen here, and I'm going to use Pari script now. So I'm just going to take Pari script from wherever you put it, Pari, which is in here, I think. Programming help. So it's this. There we go. So there's Pari script ready to go once more. I'm just going to make the script executable. We'll talk about that another time as well. And if I now run it, we get the same output as what you saw on my Linux machine. Okay. Now, what I want to do, and the background thing works here as well. I can do that too. Okay. Now, what I want to do, I'm going to open another window. All right, and I'm going to run the script again normally. Okay. If I run it's a bit different on my Mac, right? But ignore that, okay? If I run the equivalence command on my Mac, I don't see Pari script here in the list of processes, okay? That's because it's already finished running. Okay, I can't see it here. So it finished before we got this report of all the running processes. So what I'm going to do, Pari, I'm going to butcher your script. Well, I'm not going to butcher it. That's a figure of speech. I'm going to change it slightly. I'm going to make it sleep for 2 minutes. If I put this into your script, Pari, the script execution is going to stop and wait for 2 minutes at this point before it runs anything else. Okay, and I'm going to run that now. Can everybody? Oh, sugar. That might be another thing that's being interpreted differently on the MacBook. I'd say it is, yeah. Okay, it's waiting now. Okay, so I think I have it now sleeping for 200 seconds. Okay, so I've run Pari's script, but unlike before, we don't see any output from the script. Okay, that's because this process is now not doing anything. If I run ps-elf here. Do I see it? Oh, this really sucks trying to do things on Mac. Bear with me now. Oh, there it is. There we go. See that there? Look, there's sleep 200. There's the sleep in Porrig script. And actually, I can actually see there the IDs of the processes. So 29630 and 29631. So I'm going to do PS minus ELF, and I'm going to grep for the ID 29630. Now, you'll note this is Porrig script, the generator.sh. This is it, this bash script here. You'll note there's an S icon here. See that S icon, right? That means that process is waiting. So that process, guys, if we go back to our list of the states we have, that process is now blocked. It's now blocked because it's waiting for this sleep instruction to finish executing. And after 200 seconds, it will finish and it will go back to running. You'll note here on the grep one, for example, on this example, we have an R. The R means that process is actually running. So that process is either running or it's in the ready queue. It's not blocked. Okay, it's not blocked, it's not waiting, it's running. Whereas these two processes here, sleep is its own process being triggered by Porrig script. They're now both sleeping. Sleep is sleeping because that's what it's supposed to do. And Porrig script up here is waiting for the sleep to actually finish. Okay, so the S here indicates that the script is blocked. Okay, if I go back into my virtual machine and I run PS minus ELF again in here, oops. PS minus ELF. We can also see those characters here. There's the S. Look, there's the S for something that's sleeping. And there's the R for something that's running, which is my PS command there. So that's a difference, everybody, right? From Process Explorer that we saw last week. Process Explorer in Windows was just showing us a bunch of processes. We determined that some of them are sleeping because they had 0 CPU utilization. But here, one of the nice things about Linux, because it's the real computer guy's operating system, it's actually giving us the information we want about our processes. We can see what's sleeping or what's blocked and what's actually running. That's one of the nice things about working on Linux, okay? Ian, you have questions in the chat window. How does the process count time if it's only being run every so often? Like, how does a program keep track of time if it's only being run part of the time? Can you elaborate a bit more on that question, Ian? When you say how does a program keep track of the time, do you mean the time that you can see kind of here and on this on my terminal, or do you mean something else?
Like how the Python program has to wait 200 seconds. Is that kind of like, how does it actually count time? Because it's only being ran part of the time. So
Right.
how does it know how much time has elapsed?
That works by means of something we haven't talked about yet. That works by means of something called an interrupt, right? That shell script, right? That's a program that's running, right? And it's so Porrig's program, generator.sh, has called sleep. Sleep is another program on the Linux system, okay? So what you're essentially knowing is how does the correct question really there is to ask, how does sleep know how to terminate after 200 seconds, right? Porrig's program, generator.sh, is waiting for sleep to finish, okay? And the sleep program is waiting for 200 seconds to elapse. If you think about it, Porrig's generator.sh doesn't know how long it's going to be sleeping for. The sleep command knows how long it's going to be sleeping for. The generator.sh is waiting to receive a signal from the operating system to tell it when it is actually finished. So in terms of your question, then the sleep program, when does the sleep program know how to wake up? So that works because what happens is your operating system, by means of help, your motherboard in your system, right, has a clock. Okay, there is a clock on your motherboard. I'm not sure if any of you ever opened your system, and we'll be talking about this maybe next time or the week after. Your motherboard has a battery on it, right? That battery is required by the motherboard to keep track of time when the computer is turned off, right? So, and that battery can run out. In fact, it happens on my one a lot. But so your motherboard, your hardware is what knows the time, okay? Your operating system is alerted every single time the time changes, right? So whenever your system clock on your motherboard actually moves forward a tick in computer architecture, when time moves forward, we say it's moved forward a tick, right? Every time time ticks forward, a signal is sent from your hardware that's received by your operating system. Your operating system knows how to receive that tick, okay? So the operating system always knows what time it is, okay? Now, the sleep program, in the case of the way I've hacked Pari's script, the sleep program has been started and it knows it has to sleep for 200 seconds. So if I was the developer of the sleep program, I would know that, okay, I would know what time it is that I've started up and then when I want to go to sleep. And what's going to happen is that it's going to tell the operating system that it needs to receive a signal after 200 seconds to let it know that 200 seconds has elapsed. The operating system itself, which knows the time, right, is now scheduled to send a signal to the sleep program when 200 seconds has elapsed. And that signal is something known as an interrupt. Okay, so the sleep program will receive an interrupt from the operating system when 200 seconds has elapsed. When 200 seconds has elapsed, the sleep program will stop executing. It will go into the killed state or the terminated state. And at that point, Pari's program is going to continue executing because it will no longer be waiting for the signal for the sleep program to indicate that it's finished running. Okay, so long story short, your operating system, which knows the time from the hardware in your computer, is scheduled to send a signal to the program. Your observation is correct, Ian, that if the program is sleeping, if the program is suspended, it's not running. It's not keeping track of the time itself. The operating system is keeping track of the time on behalf of the program. And the operating system has been scheduled to send this signal to the sleep program after the desired amount of time has elapsed. Does that answer your question?
No, not quite. No, I think you could go on for a bit longer.
Okay. You and I need to schedule some additional time to talk about this. Yeah,
Thanks, Michael.
so you're very welcome. Yeah, it was a very good question. It's a very, very good question, actually. Okay, but I was going to be talking about these interrupts and these signals in a future session. So now you're sort of prepared for that, okay?
I've got a quick question there.
Sure.
Is there any this by the way, your answer to this could potentially ruin my day.
Oh God.
Yeah. Is there any problem with me using the same FE system partition as Windows in Linux?
You want to know if you can install Linux into the same partition as Windows?
It defaulted to it.
Oh dear me. I don't think there is an answer I could give you that would salvage your day, because when you install Linux, it wipes that part, the selected partition. So if your install has kicked off, Kyle, then
I think it automatically, yeah, but see, it didn't actually. When I hit install, it's like came up with a list of partitions it was going to format.
Right.
And the part of my NVMe drive that it said it was going to use as an FI system partition, did not show up as one of the ones it was going to format. I double checked.
Right.
So I'm not sure why, but I think it's something to do with dual booting Windows and Linux that it just defaults to it. Maybe. I don't know.
Normally when I install Linux on a system, I would create a new partition on my hard drive, and then I would.
I wouldn't have installed partitions. So what I did was I actually used Windows Disk Manager.
Yeah.
And just mapped out all the required partitions there.
Yeah.
Except for the A5 partition.
Well, the thing is, to create a partition in the Linux installer, you need in your Windows Disk Manager, you need to have something called free space, which is
Yeah.
not a partition.
I know.
Oh, you know that? So you had that, did you?
Yeah, I set up all the partitions in Windows Disk Manager,
Yeah.
restarted, went into Linux, and then manually set up all of those partitions as like, /home/boot.
Well, Kyle, good luck to you, and let us know the outcome of that.
Yeah, it doesn't seem to have like crashed yet, so I'm not sure if it's just replaced all those files, and I'm going to have
It should. Your Linux should technically be fine, but your Windows, I don't think will have survived that.
Well, I already had to reinstall it yesterday because I kind of accidentally formatted it yesterday when trying to do this.
I see. Well,
So like I don't have anything important on it because I already wiped it yesterday.
that's good. Okay, so we don't need to do like a collection at the end of the session for people to donate pennies to buy you a new Windows license.
We do not actually. Funny story. I actually KMSP coded the first time, and it tied to my account. So I did. So I not only do I have Windows activated through my account, it's also not. I also don't have to like. It's also not as sketchy.
Good. That's good. Less sketchy equals good in my book.
Agreed.
Yeah, that's why it sounds like the dorkiest thing anyone's ever said. But anyway, less sketchy equals good in my book. That's something I must never ever utter again. Okay, thank you for sharing that story with us, Kyle, and my commiserations to your Windows system from yesterday.
Well, you know what? I didn't have anything important on this to begin with. I don't have important stuff. Do I look like I have a job?
That kind of thing has happened to people here. I won't get into that, but anyway. Okay, let's crack on. Okay. Does anybody have any more questions about anything? Because what I want to do now is I will use Pori's program for another demonstration, and then we're going to look at some cool Python programs. Anybody want to ask anything else along the lines of what Ian said or anything else? Good. It's a good thing we're recording this because there's a lot of material in this. So we've learned a fair few pieces of information here, like the PID, like the process ID, the owner of the process, whether it's sleeping or running, what time it started, what's the command of the program that's actually running, and some commands to go with that. Okay. So processes, they're wonderful. Now, what I'm going to do, I want to come back to my Linux machine, which is where I am at the moment. Okay, so what I have here, I have some files here, and to finish off today, what we'll do is we'll go through a few of them, and I'll share this code with you because I hope people would learn from some of these Python programs and do some cool stuff with them, right? So what we're going to do, I'm going to show you Porig's program again, which is this generator.sh. So there's Porig's program, okay? And what we also have here is I have a Python file called program.py. I'm going to show that. This is a very simple program, but it's something in Python you've never seen before. This is a demonstration of how you can actually launch system programs or scripts or run system commands from within Python, which is not always a good thing, to be honest, but it fits well into the discussion of what we're having today. Look what I'm doing here. So I have to import a module in Python called subprocess to do this. So I'm creating a variable called result, and I'm letting it equal subprocess.checkoutput. So that's a function. We've seen lots of functions already in Python, like prints, inputs, and things like that. This is another function. It's called checkoutput, and it lives in the subprocess module. And what it's going to do is that command is going to run Porig's program on my Linux system. So rather than running it just like this from my command line natively on Linux, what I'm going to do is I'm going to get the Python program to run Porig's program. Isn't that exciting, Porig? Your program is going to new heights here. And I have to use Python 3 for this, by the way. Program.py. There we go. So that Python program just executed Porig's program, and we got the same kind of output as well. Paste, type out. And it inserts a new line after every character. Okay. So there we go. So that's something cool you can do with Python, is you can actually start processes in Linux. Okay, and you can run commands and you can get the output as well and use them in your Python programs. Now, the other thing I want to talk about today to finish up is I want to talk about files. You're all familiar with files on your own laptops. For example, a lot of you will have worked with HTML. You'll have done websites at our dojo, and we're actually going to be looking at some HTML in a few minutes, right? So when you create a HTML file, like Michael's website, that is a file on your system. If I run ls here, I can see some of the files on my system. I have 1, 2, 3, 4, 5, 6 files in this folder. I have I have 4 Python files. We know Python files because they end in .py. I have the Linux shell scripts program, which we know because it ends in .sh. And maybe you were curious about this. I have a Star Wars.txt file. So that's just a text file, okay? So these are files on my system, on my Linux system, right? Now, I know some of you at the dojo a long time ago did a Linux class, and you would have done some of this kind of stuff with Chris Murphy, my colleague here, my friend. Does anybody remember a command that would allow you to create a file on Linux? Hands up. Niall Kelly, go for it.
Is it Nano?
I see why you'd say that, because Nano is obviously your favorite text editor, Niall, is it?
Not really.
Okay. It's certainly not mine. Yeah, but Nano will open a text editor like that, and I could write a file like, this is Niall's favorite text editor, Nano, and this is a file created using that. So I have a new file. I haven't. Oh, forgive the bad typing at the start. That's just the performance of the machine being very poor. So I'm typing a file. I haven't saved this, but if I do Command O, it will write out the file. So if I do Command O, file name, we'll just call it Niall.txt, whatever. There we go. And now I'll exit. And now if I do ls, there's Niall.txt, and if I cat the file to show me the contents of it, whoops, cat Niall. There's Niall, there's the text, okay? So you can use Nano to create a file. That is true. But what I'm wondering is, does anybody remember any commands that would create a file without using a text editor? That would just create the file. Thank you, Sean Finnegan. Touch. Touch is the command I was looking for. Touch. Touch will create a file. So I'll touch I don't know, my file. .txt.
So Michael,
Yes.
just to let you know, Linux, the Linux install is working perfectly great.
That's
and
good.
I'm considering just never checking the Windows one, so I never have to know.
That's good.
I never have to.
Ignorance is bliss.
Oh no, Windows just started up on its own.
Oh.
Oh, this could go very poorly. Just boot it into Windows. Okay, so it does work. Both of them work.
I think you'll have to give a demonstration of that to the meeting at some point, Kyle.
It just straight up works. What?
Maybe put the Linux files alongside the Windows files.
Yeah, I think that's what it did, because it didn't format it. It didn't show up as a file.
Oh, right. Well, if it didn't format it, yeah, it'll be fine. But I thought it would. Okay.
Yeah, that's what I was thinking too. But it didn't, like, it showed up a bunch of the list of partitions it was going to format, because I created them in advance.
Oh, I see. Okay.
It wasn't there, so I think I'm actually good.
Well, good. I'm so happy for you, Kyle. I'll sleep easy tonight knowing that your Windows is okay.
Thank you. Thank you. Just for anyone else trying to jailboot, it, that will not kill your system. Probably, maybe, I don't know.
Yeah. So here's a new file. Thank God. So I've said it's thank good. Kyle's window is a-okay. Windows is a-okay. So I'll say
Thank you,
that.
Michael.
You're welcome. So, whoops. There we go. So I'm going to say that. So now, touch. Touch is a file, or is a command that will create a blank file. So again, touch. another file.py. So that will create a file, but if I cat the file to see what's in it, it's empty. There's nothing in that file. So no, Niall Kelly, it's not slander, right? Creating empty files is a good thing, right? We don't always want to create files with our text editor, okay? Now, here's another question for you. So these are files, right? The other major construct we have in your system for storing data would be a directory or a folder. Does anybody remember a command for creating a folder on Linux? And here's a hint, you can't use a text editor for this. So Sean Finn has said dir, D-I-R. Dir is actually a Windows command, and dir is actually the Windows equivalent of ls. It will show you all. It will show you all the files in a directory. Obviously, I'm not. If anybody there is on Windows and you open a Windows command line prompt and type in dir, it will show you all the files that are in the current folder. Okay. So it's not dir, not for Linux. No. Anybody have any other suggestions? But it was a good guess, Sean. Very good guess. You're in the right space. Any other suggestions? Okay, so to create a directory in Linux, and these are the kind of commands I hope you're learning, right? Just try and memorize these. mkdir, which stands for make directory. Make directory, mkdir. So if I do mkdir and I might call it my folder, and I do ls, I now have a folder there, my folder, and I know it's a folder on my Linux machine because it's in blue, okay? I can go into that folder by doing cd, my folder. Well, if I do cd correctly, of course. My folder. So now I'm in my folder, which is beneath, look at the directory structure there, guys. My folder, I'm sorry now, this is probably very simple to a lot of you, okay, but bear with me. My folder is inside the virtual computer science folder, okay? So we've got virtual computer science / my folder. That's the directory structure there, the hierarchy, okay? All files in an operating system have a hierarchy, and we'll be looking at the top of the hierarchy. If not today, we'll do it next week. Learning a bit about file structures. This is the other important thing I want to get across to you about operating systems. So we have our folder. It's empty. If I do ls, yeah, it's empty. There's nothing here. So I could put another file in here. I could touch new file.txt in here. Again, I'm gonna have to try and sort out my performance problems on VirtualBox. Touch new file.txt. And if I ls now to list the files, now I have new file.txt inside my new folder, okay? Now I want to go back. I want to go back up to the virtual computer science directory. So to do that, I can use cd. And if I do .. that takes me back up one level to the virtual computer science folder, okay? So files and directories, very core building blocks inside in our operating system for representing data, okay? Now, in Python, you can write to and read from files on your system. Okay, and that's what I'm going to finish off with today. I want to show you a demo of these, because these are the kind of things I'd hope in some of your own personal projects that you can use and put to good measure. Okay, so I have a couple of files in here. You can see there, one of them is called filereader.py. Okay, so what I'm going to do is I'm going to open that program, file reader. Very small. And this is how we can open a file on your operating system in Python. There's many ways you can do this. And I'm sure in Alan's mind and in Caleb's mind, they're probably going, "Oh no, Michael, why are you showing it showing people how to do it like that? You could do it this other way and this other way." But we're going to do it this way, okay? So Python allows us to open a file on our system to read the contents of it with this construct here, with open. And then inside in the brackets, I put the name of the file that I want to read. And in there at the moment, I have starwars.txt. So it's going to open which is a text file over there, starwars.txt, and it's going to open it, and we'll then be able to access that file using this variable here, which I've called file, right? So I'll be able to access the starwars.txt using the file variable, okay? I'm going to keep a counter of how many lines I read from it, and what this thing is it's going to read the lines one by one from that file. To read the first line, I do line equals, so I'm creating a variable to hold the first line equals file.readLine. So that's going to read the first line out of the file and store it in the line variable. We check here, we're going to do a while loop then, because we want to loop over every line in the file. Okay, we want to print out all of the lines of the file, not just one line, okay? So we have while line, okay? So while line, what this is essentially saying is while line is not empty. While line is not empty. When we reach the end of the file, file.readLine will return blank, at which point line will be empty. So this says while line print. Hang on. Oh yeah, no, sorry, this is correct. Yeah, sorry. We're going to print out the line. So I'm going to do print. We've seen the print function. It will print out to our console. Print line.strip. So the strip is just going to remove any white space that we don't want around the lines. So it's going to print out the line to the console. We then read the next line. And then I'm just using a counter to count up how many lines we read. So I start off with line count equal to 1. And each time we read a new line, we're going to increment the counter by 1. So let line equal file.readLine. And then this is a while loop. So it's going to, we have a question. Niall.
Oh, sorry, I was going to ask after you're finished, if you want to continue.
Okay, you can ask now, it's fine.
I was going to ask, why can you do while line? Isn't line a string?
What line? Well, no. Line is a string, right? But what's actually happening here is that the way Python is interpreting that line there is that it's essentially while Niall, just interesting choice. While expects a Boolean, right? So we've seen while loops before a bit. While expects there to be a Boolean condition here, which is either true or false. Okay. So what while is doing is it's interpreting this string variable as a Boolean. If there is actually a string in that variable, Niall, that's not empty, the while loop is going to interpret this as being true. Whenever there's no more lines left in the file and the line variable becomes empty, the while loop here will interpret it as false. And that's why that works.
Ah, that makes so much more sense. Thank you.
Yeah, is that okay? So
Yeah,
so think of it as saying while there's still lines, while it's like saying, are there still lines here? Yes, there is, because line is not empty. So are there lines? That's true. Okay, there's still lines left. Okay, so that's why that works. Very, very astute observation there, Paul. Well done. To notice the data type match up there. Very good. Okay, so that answers the question now, does it?
it does.
Perfect. Okay. Right. So while it's true that there's still a non-empty line, print out the line to the console. Set the line variable to be equal to the next line in the file. File.readLine will always return the next line that it hasn't yet read. Okay. So after it's read the first line, file.readLine will give you back the second line. After you've read the second line and you call file.readLine again, it will give you back the third line, and so on until it's gone through all the lines. So then, as Niall was asking, when it then comes back up here to the while loop, line will now contain the next line that's available in the file. So this will be true and it will proceed to print out. Eventually, when it gets to the end of the file, file.readLine will return empty. Then when it comes back up here, while line will be empty, so it will interpret this as false, and it will then go on past the loop into file.close. Okay, and what it's going to do then, I've asked it to print out red however many lines, right? So we're gonna run that now. So we're gonna do, sorry, I'm gonna do Python 3, Python 3 to run it, and we're gonna run file reader.py. There we go. There's all the lines from the Star Wars.txt file. It's printed out each line on a new line. That's one line there. It's one long line there. Actually, I should have broken that up into another line there. And then it says read 6 lines. So 1, 2, 3, 4, 5, 6. Okay. So that's an example of how we can use Python to read files that are sitting on our operating system. Okay. Now, bonus marks for whoever can tell us which Star Wars film that this opening text came from. Hands up. Daniel Murphy, go for it.
The second one.
Daniel, it was the first one. It's episode 4, A New Hope, the very first Star Wars film. Close though, you were close. That was my favorite question of the evening. Okay, very good. Okay. So this is where Princess Leia is going to try and outrun the Star Destroyer upon her Starship Custodian, you know. So yeah. Anyway, that's not relevant. Anyway, so there we go. There is a reading a file with Python on our operating system. Okay. Very good. So now I have a question for all of you. I'm going to come down into my new folder that I created earlier. So I'm now inside new folder. I'm 1 level down. My Python program is back up 1 level. So if I want to run it from here, I have to do Python. Now if I again spell it right, Python. And I need to go point upwards to the program. Python. So I want Python 3. Python 3 dot slash to go up 1 level, and then the program is a file reader.py. Oh no! Oh no! The Python program fell over on me. Can anybody tell me what went wrong here? Hands up. Why didn't this work? It says file not found error. No such file or directory Star Wars.txt. That worked a minute ago. Why is it not working now? Anybody? Niall.
Is it checking it based off of where you've run the command?
That is correct. Yes, that is 100% correct. So I am in the my folder, right? Look at the code of the program again. It says open starwars.txt. The way that's specified there, it expects starwars.txt to be in the folder that I'm currently in, right? But there is no starwars.txt in the folder I'm currently in, so it can't find it. That's why it says file not found, starwars.txt. Okay, so if I wanted to do a better job of that, what I should really do, I'm going to edit the file. Come on, edit reader.txt. And what I should really do is I shouldn't really specify the name of the file like this. What I should do really, what I'm going to do is give what we call the absolute path to the file on my system, starting from the top of my hard drive, the slash, right? home/Michael / this might be awkward now, yeah, because my keyboard isn't working properly on my VirtualBox. Did that even update? It did, and it didn't even show me. Now home. Michael. Yeah. Virt. My folder name. Comp. Sci. /starwars.txt. So what I'm doing now, rather than just saying starwars.txt, I'm giving the full path to the file on my system. Okay, I'm going to save that and close it, and now I'm going to run it again. Now it works. And if I go back up to the original location and run it here, well, that's wrong, of course. I've now given the wrong path to the file. And I run it from here. Oops, Python 3 file reader. That works as well, because now in the file, I've given it what we call the absolute path. This is the absolute path of where the file is located on my system. Here's another Linux command. If I run pwd, which most people think stands for password, it doesn't. It stands for present working directory. It says it's home/Michael/virtual computer science, and the Star Wars file is in this folder. That's the full path there. It's called the absolute path to the file on the operating system. The way it was originally, where we had just starwars.txt, that's what's known as a relative path. That's relative to where you're running the program from. And that's not very desirable unless you can guarantee a particular structure, right? Absolute path is probably the safest way of doing these things, okay? So be mindful that there's different ways to refer to where our files sit on our operating systems, and there is a hierarchy of files and folders, and these need to be correct, okay? And we will be talking a bit more about that in the future. I just wanted to give you a demo today. And to finish off today, we're going to look at the last Python program, which is the filewriter.py. So we've looked at how to read files in Python. We're now going to look at how to write files to the operating system in Python. So I'll run it first, and then we'll look at the code. I'll keep it as a surprise for you as to what it's going to do. I'll keep you in suspense. So Python 3 filewriter.py. Rise is asking me a question. It's some input. What is my name? So I'll put in my name, Michael. What is your favorite hobby? So I'll say flying, which I haven't done since the pandemic started and won't be doing for a long while yet, I'd say. Okay, now I
I
finished.
like how you brought that up so casually.
I know, yeah.
I like flying, you know, as you do.
Yeah. Somebody stole my bike travel, one of my bike travel videos this evening. They took screenshots of my video, popped out the logo, and posted it to their own Instagram without giving me credit. So
So basically the internet is full of amazing people.
oh yeah, very creative, talented people, yeah. Okay, I probably should have put a message here at the end to say what's happened, but I'm going to do an ls here. Oh, look, guys, I have a new file, index.html. Let's have a look at that. In fact, I won't look at it like this. What I'm going to do, if my system will be cooperative, I'm going to open my, there we go, file system. I'm going to open Virtual Computer Science. So it looks like it's written a HTML file for me in Python. Wow. Come on, open for me. Again, that's not the WebEx being sold. That's my virtual box being a nuisance. There we go. Index.html. Let me open that. So hopefully it'll open in Firefox. Come on. Don't make me go back to the terminal after coming in all the way here. And now it's highlight. Oh, here we go. Here we go. It's all being Chrome. Michael's website. My favorite hobby is flying. So I used Python to write some HTML for me. Isn't that cool? Is that not the coolest thing you've all ever seen?
I will admit it is kind of cool that you can get websites to auto-create for you. That is quite nice.
How did I do it? This is the last thing we're going to look at. I wrote to a file in Python. So I used the input function to get my name and my hobby. I then created a string variable called title, and I had a h1 for a header 1. I put the name variable into it. I'm using the plus symbols here to join the strings together. So h1 joined with the name variable, which was Michael for me, joined with 's website. So that's how we got Michael's website. Then intro is a paragraph. There's the p tag. My favorite hobby is Then I'm joining in the hobby variable there, which I said flying, and then closing off the p tag. Forgive me, I didn't put in the opening HTML body tags, all that kind of thing, but you know they're supposed to be there, but it'll work without them. Shh. Okay. Then here's how I write the file in Python. This again, there's many ways of doing this in Python. I use with open again. I point at the name of the file, which is going to create for me because it doesn't already exist. And I say W. I have to give a second parameter here, W, which means open the file so that we can write to it. Otherwise, if I didn't include the W, it wouldn't let me write to the file. We then have our variable again, just like we saw in the last program file, and I can do file.write, and I can simply pass in the string variables that I want to write into the file, title and intro, and I just put a new line at the end of them just to make it look a bit nicer. So if I cat the index file, cat index, oh Jesus, cat index. It just put with the backslash n characters. It just puts each line, each HTML tag on a new line. Okay, so there's how we can write a file to our system to our operating system using Python as well. So we've seen how to read files and write files with Python. So I'll make all this code available to you so that you can play around with it as well. Again, there's lots of different ways of doing these things. I just wanted to keep it simple for all of you tonight. So I didn't want to be diving. This isn't all about Python, you know. I just want to demonstrate that we can use Python to write files and read files in our operating system for different purposes. Okay, that's it for today, my friends. We've looked at a lot of stuff today, lots of commands, looked more at processes in Linux and how to use the
I didn't kill Windows.
And you didn't kill Windows. That's the big achievement of the night. And we saw PowerX shell scripts and you know, so we had a very interesting question from Ian about the clocks. We looked at the Star Wars Episode 4, A New Hope text crawl. You know, all these good things. Does anybody have any questions for me to finish up with? And if I'll stop the recording now in a minute, and if you want to ask a question off the recording, you can do that then. But I'd like to have good good questions on the recording if anybody has any. I take that as a no. Okay. So no exercises for today or anything. Next week, I will plan out as the week goes. We'll either look at operating systems for the last time, or we'll move on to computer architecture and hardware. And if we do that, I might actually do that, and then we'll revisit operating systems one last time, because some of the things you were talking about the week before is we were talking about threads and things like that in terms of process management. I can't really talk about those things until we talk a bit more about computer architecture and computer hardware, right? So what we might do next time is talk about computer architecture and computer hardware, and then when we understand those topics, we'll come back and look at operating systems for the last time. Okay, that would be my agenda before we move on to our next topic, which will.
I just.
Go ahead.
You know the issue you said you had with VirtualBox?
Yeah.
When it was like zooming in all the time, yeah, you can actually fix that
it's typing in more characters than I'm pressing on my keyboard.
No, I was on about the one where it was zooming in all the time.
Oh yeah. Mm-hmm.
Yeah, you can actually fix that in the Linux settings with the scale option and display settings.
I can't. Whenever
does that not work?
In my VirtualBox here, when I go into those display settings to access the scale, the VirtualBox freezes for me. There must be something wrong with the graphics driver.
Some tomfoolery.
Yeah.
You should double check your drive. Oh, this is a Mac. You can't get drivers.
That's right.
Okay, yeah, that would make sense.
Yeah, like given the way this happened tonight, I'm almost tempted to put VirtualBox on my own Windows laptop, and the next time we look at VirtualBox, I'll do it from there, not deal with any of this kind of rubbish. I'm sorry.
You'd have much better driver support and stuff like that.
Yeah, for sure. Yeah, I'm sorry now, guys, about all the weird typing and whatnot tonight, but look, that's the way it goes. Okay. Any other questions from you guys before I stop the recording? Okay, bear with me and I'll stop the recording. And then if you want to ask something that's not on the recording, you'll be able to do that. And I'll make the recording available as a private video on the YouTube channel. Obviously, please don't share it publicly. Stop.